Say it again.
1.36.
Oh. That's the one I wanted. 1.36.
Volts.
Thank you. So this was 12 volts going across here. Going across here, or just put it in the middle, we have 1.36 volts. So now I know the voltage going between these two junctions. I can find the potential, I can find the current flowing across each of these. So the current flowing across each of these, well, how would I find it? I know voltage, I know resistance.
Voltage divided by resistance.
Say it again.
Voltage divided by resistance.
Oh, okay. I can multiply in there somewhere. Next Monday, I'll be able to hear again. And so the current flowing across here would be the voltage divided by resistance, as Luis said, and this one I'll do, that's 1.36 amperes. And this one, 1.36 divided by 2, 0.68 amperes. We can double check our work at this point, because it splits into 1.36 and 0.68, 1.36 plus 0.68. Got 4, carry the 1, 0, carry the 1, 2.04 amperes, which there's some rounding here, but we had 2.045 coming in, and we added it up to 2.04. That's a rounding thing. So I now know the current flowing split across that, across each of those, so we have this last one remaining. I know the current flowing across the combined. So now I need to figure out what's my potential drop across here. How would I do that? I know the equivalent resistance. I know the current. How do I find voltage? That's the one. And so my voltage here is going to be 2.2 ohms times 2.045 amperes.
4.499.
4.499. And so my potential drop across here, 4.499 volts. I now need to figure out the current flowing across each of these. Actually, let's check our work first. I gained 12 volts going across that. And then I'm going to lose 1.36 volts. Then I'm going to lose, going across here, did we find the voltage there? We didn't. Oh, let's find the voltage here. The voltage here, 3 times this, I times R, or R times I, the way I'm writing it. 6.135. That's right? Okay. Minus 6.135 minus 4.499. That should come pretty darn close to 0. Or if I add those up, that adds up to 12. So 1.36, 6.135, 4.499, 4 carry the 1, 9 carry the 1, 9 carry the 1.
11.95.
Oh, sorry, that's pretty darn close to 12. All right, so feeling good that we're doing something right. All right, so now the currents. I have the voltage across these resistors. I know the resistance of each. Finding current, what's the magic words?
Ohm's law.
That's the one. And those are the ones. And so the current flowing across here, we get 4.499 over 4,
1.125.
1.125. And across here, 4.499 over 5,
0.899.
0.899.
899.
So I have current flowing across here of 0.899.
Amperes.
Thank you. And across here of 1.125 amperes. We can double check this because we have 2.045 amps flowing into it. We have to have the same flowing out, and the sum of these needs to equal that. And we'll squeeze it in down here, 1.125, 0.899, 4, carry the 1, 2, carry the 1, 0, carry the 1. A little bit more off than I would like, but darn close. Yes, Abby.
How would we know how many uses to round to?
The fewer the resistors, the fewer that you need to round to. For the most part, show your work, and that's fine. There is a lab that we do some semesters where I specify, take it out to, I think I say at least 4 decimal places. But if I don't specify, just 3 significant figures is fine. Now, seeing how jazzed up all of you are, and knowing that you're thinking, hey, can you make it even more complex? Let's do it. Now, we'll set it up and we won't be able to finish. Not quite what I have done before. I think before I had it here. Anyway, it'll do. The resistances, we'll make this 1 ohm, 2 ohms, 3 ohms, 4 ohms, 5 ohms, 6 ohms, 7 ohms. Now this is the type of configuration where 4 decimal places. Let's make this a 20-volt battery or power supply. And all right, we're going to go through the exact same steps. First, we need to find an equivalent resistance. So which ones do I combine first?
2 and 3.
Yep. So 1 over the equivalent resistance of 2, 3. is 1/2 plus 1/3, which is 5/6. So the equivalent resistance of the 2,3 is 1.2 ohms. So this is 1 ohm. Okay, there. This is B, C, D, E, F, and G. 4 ohms. This is 1.2 ohms. This is 5 ohms, 6 ohms, 7 ohms. All right, now what?
E and F. E and F.
Series or parallel?
Parallel?
If they're parallel, then there should be a junction at both ends of it and nothing in between. But I've got a junction, F has these two junctions, E has these two junctions, so they don't even have the same junctions at each end, so cannot add E and F yet.
Is everything else just series?
Say it again?
Is everything else just in series?
No.
No?
I mean, the next thing it's basically we're gonna flip back and forth between parallel and series. Which one we start with depends on the configuration, but we just did a parallel.
Okay, could we do the 1.2 ohms and the 4 ohms
Yeah.
in series?
Those are series, because going across this, there's no place for the current to go anywhere else other than across that, so those are series. So those will combine. Since they're in series, into 5.2 ohms is the resistance of B, C, D. Now what? Just do this last one and then we will look at this cliffhanger.
Would that be in parallel with the 5 ohms?
Yes, it is. All right, I got this long wire right here, but we are considering the wires to have no resistance in circuits like this. When we draw the circuit up there, if I want to include the resistance of the circuit on a circuit analysis, I would tell you what the resistance is of the wire. So it would be bundled up in everything else. So this right here is a single junction. I drew it like I have a wire there, but in essence, I have these two are on both sides of E and on the BCD combination. So they are in parallel. So 1 over the equivalent resistance of B, C, D, E would be 1 over the resistance of BCD plus 1 over the resistance of E, which is 1 over 5.2 plus 1 over 5. And so we end up with the resistance of B, C, D, E to be, so share. And that is 5.2.
So, when you add up 1 over 5.2 plus 1 over 5, right?
Right.
And then you flip that.
Yes.
Okay, so that as a fraction was 22 over 13. So then flip that would
This
be
is equals 22 over 16,
13.
13.
So then it would be 13 over 22, right?
Which would equal
of 22 over 13.
Yes.
So what did we end up with in the end?
0.509.
No, wait.
590.
Okay, this can't be 22 over 13. If you add those together,
I lied. That is the,
that's the final.
that is, yes.
And the
I think
0.509 that
maybe
you
I've
said,
just
Abby?
messed up. Hold on.
Wait, then that would be wrong.
Yeah, got to take the reciprocal.
Hold on.
I got 2.55.
Or, yeah. Because if it's 1 over 5 plus 1 over 5, that would be 0.4. Flip that, you get 2.5, so this is slightly off that. All right, so my circuit has now been reduced to, I got my 20-volt battery here, I've got my 1 ohm resistor there, I now have a 2.5, is 4 decimal places, what would it be?
2.5490.
5490.
Yes.
2.5490 ohms. So that takes the place of that. And then that splits across the 6 ohm. And I'm trying to draw that right, so that combines into 1. Because this end of it, it connects in between the 1 and the 7, and at the other end, it connects at the 6. Okay. All right. We'll leave it there for now. We'll come back to it. And if I don't get too distracted, I will actually write this down so I don't have to ask somebody. Of course, then I have to remember to actually bring it. Starting out with and maybe we'll stop it. As compelling as a video of me writing stuff down. I've got plenty of that.